Good day everyone, I am Angelica taking up with the Bachelor of Secondary Education, major in Sciences at Northwestern Mindanao State College of Science and Technology.
So, good day everyone. By the way, I am Angelica from Bachelor of Secondary Education, major in Sciences. So, for today's video, I will be going to express what is Pascal's law and give a real-world example of it. Whenever any pressure is applied to any part of the boundary of a confined fluid, it is transmitted equally in all directions, irrespective of the area of which it acts, and always acts at the right angles to the surface of containing vessel. So, applying Pascal's law, we can see that in a simple hydraulic system showed in a picture, so that a force applied to the input piston from here results in pressure, which is transmitted and diminished through the liquid and acts on all portion of the interior of the containing wall. So part of the interior of the system on which the pressure acts is the output piston, so right here, which moves when the pressure acts on it. So we are already familiar with this type of hydraulic system, and let us modify the system slightly by squaring the corners until we now have the simple diagram of a hydraulic jack. So we have in this system a small input, or A piston, a larger output, or B piston, both of which are pushed with the oil, which is completely confined with the system, and the input and output pistons are free to move when the force is applied to one of them. Okay, so now let us apply a 50 pounds weight to our input piston. So this would be our 50 pounds weight in the input piston, which has an area of the bottom surface of 1 inch squared. So if the weight of 50 pounds on the input piston acts on the area of 1 inch squared, then the pressure on the input piston would be 50 pounds per inch squared. So this pressure of 50 pounds per inch squared, as Pascal's law states, that transmitted and diminished through the system and acts on all portions of the interior of the containing wall, in actual practice begin to put piston with the 50 pounds weight on it would move down and displace oil, which would move the output piston up this pressure of 50 pounds per inch squared. Transmitted through the system acts on the output piston. So this would be the output piston, which is free to move the area of bottom surface of the output piston on which this pressure acts in the area of 2, or area of sub 2 is equal to 5 inches squared. And hence, the total force acting to push the output piston upward is the pressure, which is the 50 pounds per inch squared times the area, of which it is the 5 inches squared. So the total force on output piston is equal to pressure times area, and in which 50 times pounds per inch squared times the quantity of 5 inches squared is equal to 250 pounds. So this gives us a total force of 250. So this gives us a force, or a total force, of 250 pounds, which is necessary to balance the weight on the input piston. So here we are purposely neglecting friction, which is small, and also the weight of the piston in the system. As it is shown here, the weight would just balance each other, a very small additional force on the input piston would cause it to move down into displaced liquid, which would move the output piston upward. So by the way, this is the input piston and this would be the output piston. So the input piston would cause it to move down and to displace the liquid, which it would be moved the output piston upward. So the 50 pounds weight on the input piston will just lift the 250 pounds weight on the output piston, and so we see that the 50 pounds weight on the output or the input piston rather can move to a 250 pounds weight on the output piston. So the 50 pounds weight moving the input piston through a large distance. So through a large distance and the output piston exerting a 250 pounds total force through a small distance. So this would be the large distance and this would be the small distance, and it goes upward on the output piston.
So let us take note that Pascal's law, this has numerous applications in everyday life. So Pascal's law underpins a number of devices, including the hydraulic lifts and hydraulic brakes. In all of these devices, fluids are used to transmit pressure. A hydraulic lift consists of two pistons separated by a liquid-filled space. So that's how we expressed Pascal's law. Thank you and God bless.